Hi, I hope everyone's doing okay with the material. I know that we're getting to a really quick start and things are going to start rolling really quickly. Again, feel free to send me any emails if you have any questions about the material or what you're reading in the textbook. And don't forget that you also have access to a discussion forum on Canvas that will allow you to ask questions to your peers, or sometimes, as I've mentioned a couple times now, I promise I won't keep saying this, I will sometimes hop in there and answer questions myself. So we're still in chapter 1, and this video is going to be about frequencies, which is basically those are counts of scores in the data set. And I'll also talk about tables, histograms, and distributions. So all of this together, this entire video, is about how we display a group of numbers. So let's start with frequency tables. If we consider an example to work through, we could ask each of 10 students to rate their level of stress currently on a scale of 0 to 10. This would result in a list of scores, one for each participant, and that participant's score will reflect their current stress level. So we'll say that a score of 0 is no stress, absolutely none, and a score of 10 is I'm super, super stressed out. And I'm sorry, we have 30 students, so we have a list of 30 scores. So you can see here that participant 1 had a score of 8, participant 2 said they were a 7 out of 10 stressed, and so on. So this is our data. We're going to use our data to make a frequency table. So to make a frequency table, the first thing that we're going to do is make a list of each possible value from the lowest possible value to the highest possible value. So remember, this stress scale ranges from 0 to 10. So the lowest possible score a student could have picked is 0, and the highest possible stress score is 10. So we'll just go ahead and create a column that is a list of all the possible stress ratings. So that's really simple. That's step 1 of making a frequency table. Okay, step 2 looks a little bit more complicated, but it's actually quite simple. We're going to go through our data, our list of scores, and we're just going to put a tally mark next to the stress rating for that individual score. Okay, so for example, you see that the first person had a score of 8, and then we come down here and we draw a tally mark next to the stress score of 8. Okay, so you'll do that for every individual's score in our sample. So we end up with a column that's labeled frequency that has a tally mark representing the number of times that that score occurred in our sample. So ultimately, we don't want to leave it in this form of tally marks. We actually want the actual frequency or the count associated with each stress rating. So you can see in this table 1.3 that one person had a score of 0. Also, you can see that 2 people had a score of 3, and so on. The last step, that's an optional step, is to include a third column that is the percentage of scores for each value. So you could try this on your own. You would want to figure out what percent of individuals, for example, has a score of 5. Okay, so we can see that 2 people had a score of 5. What percent of our sample is 2 people? Okay. And to do this, you would want to figure out, okay, we have 30 people total, so 2 of them have a score of 5. 2 out of 30 is 1 over 15, and you could do that math in your calculator. So if you go ahead and do that, then you'll come up with the percentages you see on the screen. You could try it on your own. You could pause the video and make sure that you can reproduce these values. And if you have any questions about it, make sure you send me an email. Now we're moving on to histograms. So we just went over how to make a frequency table. With those frequencies, we can come up with a graphical display. And that's a little bit easier to interpret than the table of values. So a graphical display for frequencies is called a histogram. That's a graph of frequencies. The first step towards making a histogram is to make your frequency table, which we just did. So step 1 is our frequency table. we have our list of possible values and the count or the frequency associated with each value in our study. Okay. So the second step for making a histogram is to put those possible values along the x-axis. Remember, the x-axis is the horizontal axis. So it should look something like this. This is an axis that represents all possible stress ratings from 0 to 10. And the next step is to create our y-axis, or the vertical axis. And the vertical axis will represent the frequencies. So this should go from 0 to the highest frequency that showed up in our table. So if we look at this column here, you see that the highest frequency is 7. Okay, so we make sure that our y-axis here goes up to at least 7. Okay, and to step 4, we are going to now start making the graph. And in this step, we put a bar above each value on the x-axis, and that bar should be at the height of the frequency for that possible score. So for example, we see that for a stress rating of 0, we had a frequency of 1, or in other words, one person in our sample said that they had a stress score of 0. So we come over here and we make sure that we have our bar height that's at 1, above the 0. Okay, so let's just pick another value and make sure that we know how to do this. We could pick, let's see, a score of 7. 7 people said that they had a stress level of 7. In other words, the stress score of 7 has a frequency of 7. So we come over here to 7 and we want to make sure that our bar height, if I can get this right, is all the way up to 7. Okay, and you would of course do that for all the values in between. Okay, and if you do that yourself, you see that you'll get something that looks a little bit like this. Now, why do we look at this? The general shape of our data actually tells us something about how the scores in our sample are distributed. So next, we're actually going to talk about different shapes of distributions and what they mean to us. We'll start first with some terminology for describing the general shape of a distribution. Distributions can be either unimodal, bimodal, or what we call rectangular. And a unimodal distribution is a distribution that has a single peak. You can see here there's a single peak in this data set. Uni meaning one, and modal meaning mode, and we'll get to that terminology later. Okay, so in the bimodal distribution, you see that there's 2 peaks, bi meaning 2. And in the rectangular distribution, as you might guess, the distribution of scores create a shape that looks like a rectangle. Okay, so the one that's a little bit confusing to understand is the bimodal distribution. So I have a little example here. You could think about the ages for a bunch of different people who are in a toddler's play area or a daycare facility. And what you see here is that we have a lot of people that are in the lower ages. And then we also have a lot of people who are in the, I don't know, maybe we could call that the mid-range, right? So if this is 0 and this is, let's say 60, right? Then we have a lot of people who are maybe 30, and we have a lot of people who are maybe 4, right? And few people in between those ages. And what you might imagine is this could be reflective of the toddlers and the teachers in the room. There's not very many people who are in between the ages of the toddlers and the teachers. So we don't have teenagers in the daycare facility. Most of the data that we handle in psychology is unimodal, and the statistical tests that you'll learn about actually require that the data are unimodally distributed. Okay. So let's talk a little bit more about other terminology that we could use to describe unimodal distributions. So after we determine that a distribution is unimodal, we can further describe it using these other terms. So we could talk about a distribution that's symmetrical, or in other words, that it's a mirror image of itself on either side of the peak of the distribution. And that doesn't have to be exact. You can see this one isn't an exact mirror image if we folded it in half, but it is approximately symmetrical. Distributions that aren't symmetric are what we call skewed. So this one, B and C, are both skewed distributions. The skewed distributions can be either positively skewed or negatively skewed. And a distribution that's positively skewed is one where the tail, what we call the tail, that's this little part here, the tail of the distribution is on the right side. And a negatively skewed distribution has the tail on the left side. With unimodal distributions, we might also observe what we call floor and ceiling effects. And that happens when you see the data looks like it's smushed up against the axes here. So it looks like it's kind of jammed up against the vertical axis. And it could be happening towards the lower values or towards the left axis, and that's called a floor effect. Or the distribution could be smushed up against the axis that represents higher values, and we call that a ceiling effect. And floor effects come up when there cannot be any values less than 0, and there are a lot of people who have low values. And ceiling effects come up when the values cannot go beyond a certain upper limit or a certain high value. So for example, exam scores on a traditional grading scale can't go beyond 100%. So you could imagine if you look at this plot here of a ceiling effect, if scores can't go beyond 100%, but people tend to be performing really well on the exam, then the distribution of scores will look something like this. It will look like it's smushed up against that 100 value. Okay, even more terminology. I know the beginning of this course is really terminology heavy, so I hope that you're bearing with me. So we're still talking about unimodal distributions here. Unimodal distributions that are symmetric can also be described more specifically in terms of these other terms. So a symmetric unimodal distribution might be normally distributed, or what we call approximately normal, if it resembles a bell curve. And you'll get kind of familiar with this after looking at several distributions. A distribution that's not quite a bell curve shape, but looks like it's sucked in on the sides, like you kind of put a vacuum in there and sucked in the sides, that's what we call leptokurtic. And so it has a sharper peak at the top, meaning there's a higher concentration of scores about that mean, and the tails are thinner. And a distribution that's the opposite of that, where it looks like you puffed out the distribution, is called platykurtic, or maybe like you put your hand on the top of it and smushed it down so the sides pop out. That's a platykurtic distribution. So it has a more rounded peak and less concentration of scores at the mean or in the middle, and they're more spread out. Here's just some terminology and background for those terms. If you're a word person, this might help you remember. And just a more general term for you to know is that both of these distributions are what we called kurtotic, or they both have kurtosis. So whether they're leptokurtic or platykurtic, both are kurtotic distributions. And I just thought this was a little cute way to remember it. This is an old article that I found that shows a platypus resembling the platykurtic distribution, and it shows these kangaroos who lep around, they hop around, resembling a leptokurtic distribution. So just in sum for distributions, I like this little chart that shows you all the different terminology you can use to describe a distribution or the shape of your data. So once you create your histogram, then you can describe the general shape of your data once you visualized it using all these different terms. So first of all, is your distribution unimodal, bimodal, or rectangular? If it is unimodal, is it skewed or is it normally distributed? And if it is skewed, is it positively skewed or negatively skewed? And if it's not skewed, is it kurtotic? Maybe it's platykurtic, or maybe it's leptokurtic, or maybe it's not kurtotic at all. Okay, and that's the end of this video. Please email me if you have any questions, and see that I've posted a couple other videos as well.